Okay, so now I'm going to press the up key and the ship moves, but it does not stop. So this would be the case where we're in maybe real space, and now I've lost the ship. Welcome back to Arcade. I am Super Tommy, and in this video we're looking at Kaboom.js, and we're going to add ship movement like from asteroids or while your ship is in space. So we're going to build off of our video on shooting bullets from a spaceship, kind of like this, just like that. So we're building off of that video. So if you haven't seen it, be sure to go check that out at our YouTube channel. We're also going to link it in the description box below. And while you're there, be sure to subscribe to the Arcade YouTube channel for more videos on making games with Kaboom.js and other web technologies. And if you enjoy our videos, be sure to hit like on this video. So what we're going to do here is add thrust so that we can move our ship like it is in Asteroids and other space-like games. So what we're trying to get at here is that when you're moving and you want to move in the direction the ship is facing, right? We're facing this way, we want to move that way. And then once you stop, you're going to still kind of float, continue to float until you kind of run out of velocity. It's going to decay based on some friction value. Now in space, I think there should be no friction or maybe very, very little friction. I'm not actually sure, but for a fun game, it definitely has to slow down, otherwise you're going to just keep going forever in some direction, and that's not very fun. Although maybe it is. You can also do that once you have the code here. Just don't decay the velocity at all. All right, now this asset that we're actually using is from Kenny. That's KENNEY.NL. Now Kenny's got a lot of great assets on his website. You can download them and use them in your own game, so be sure to go check that out. That's KENNEY.NL. He does not sponsor these videos. I just really appreciate the work that he does, and I use a lot of the assets, so shout out to Kenny on his website. That's KENNEY.NL. Okay, so now let's start adding thrust in our videos. In this project, I'm gonna go small. Now we have our ship and we have our shooter component here that you see from our shooting bullets video and our bullet component, but those don't really matter to this video. We're just building off of it here. What does matter, however, is this angle to vec2 function here. And what this does is, given the angle of our ship, it's going to return back to us a directional vector, which just means that if your ship is angled this way, it's facing this way, we want to know what the vector is of this angle so that we can then place things in front of it, right? That's what we did for our shooting bullets video. But for thrusting, we want to know that we're going in this direction. So we need a directional vector to know we're going in that direction. Now, one thing to keep in mind, I'm going to just refresh this, is that our ship asset starts out facing to the right. So this is 0 degrees or 0 radian, but this is angle 0. It's facing to the right. If you download most assets online, and even from Kenny, this ship by default is facing up. So it's more like this. But you really want it like this for simplicity of the math here. Make it face to the right. Now we are loading these assets here in our load sprite in our main.js. Now if this project structure looks foreign to you, we have videos on creating Kaboom.js projects from scratch to use VS Code and TypeScript and other things, and how to organize your code in different files if you don't want everything in a single file. But we are going to be putting all of our code here in this shooter scene for simplicity. But that's how our project is set up. So we'll link to those videos in the description box below as well. So now we can almost start. Let me just talk you through what's happening here in our scene. Our scene is very simple. This shooter scene, we're making this ship. Right here, it's got a sprite component, a position component that's posts, a rotate component, an origin, which just centers the origin to the center of the ship, and then we have our shooter component from our bullet shooting video. We're just going to add another component to our ship. It's going to call it thrust to add thrusting functionality or thrusting behavior to our ship here. So let's come up here, function thrust, and in every custom component in Kaboom.js, it's a function that returns an object, And in that object, there are different methods and properties you can add to it. But there are also some events that all components will get from Kaboom itself. That's the add event. We can do that by putting in an add function and an update event. So add is called once the component is first added, and update is called every frame. So what we want to do here is when we press the up key, we want to move in the direction the ship is facing. Now in order to move, we need to know the acceleration. So let's add an acceleration variable here. We're going to say 0.1 pixels per frame. We're going to create a velocity, and we're going to do vec2. We're just going to use the Kaboom vec2 function to make a vector 2 here for velocity. And so what we have here is we are destructuring various Kaboom functions from the Kaboom context out of it at the top here. You can also do k.vec2, for example. It's the same thing. We're just doing it this way so that we don't have to do k dot everywhere. Okay, here in add. And another thing we need to do is we need to know when we're actually moving, when we're thrusting. We're pressing the gas pedal to move. So we're going to do a boolean here. Thrusting starts as false. Now, when we press the up key, we want to do key down, up, and we're going to want to get the facing or the directional vector, like where the ship is facing. So that's where we're going to use the angle to vec2 function. Let's say the directional vector is angle to vec2. We want to give it the angle of the ship. Now, since we are using TypeScript, we can help ourselves here by typing this. If you're not using TypeScript, then this part won't apply. If you're using JavaScript, you can just ignore this part. But what we can do in TypeScript is tell VS Code that in our add function, this is going to be, since what happens here is Kaboom is going to merge everything into the ship entity, this is going to be a game object, and it's going to have a rotate component, and it's going to have that's all we need actually. Yeah, that's it. Check my notes. That's really all we need. So now this is imported up top here. These are just types, and we can even explicitly say we only need the types out of Kaboom for these things. And there that is. So now angle to vec2, we can then do this dot angle. This is the angle from the rotation component, the rotate component. And then with our directional vector, now we know based on the angle what the vector is. We can do velocity.x is going to add to or increment to the direction x times the acceleration. And then same thing for the y. We're going to do plus equals dir.y times acceleration. So this is going to change the velocity based on acceleration and direction that the ship is facing. And the last thing is we are going to say we are moving. I guess we can call it moving as well. Well, that's not technically correct. You can be moving even after you've stopped thrusting. And on key release, which we don't have here yet, but when the key is no longer pressed, so we can take key release from Kaboom, key release, go back here, key release, we want to say that we are no longer thrusting, false. So I meant this to be true. So in the key down up, thrusting true, in key release up, thrusting false. So we are pressing on the gas, and we are no longer pressing on the gas. Awesome. So in update, what we want to do is add the velocity to the position so that we actually move our ship. So just like in add, we can type our this, and our this is going to be a game object, and it's going to be a position component. Now, how do we know that? Simply because we are adding our thrust to this entity, which we know will have a rotation and have a position. So if you want it to be safer here, what you can do is actually check for this dot angle, and if it's undefined, don't do anything since it doesn't have the appropriate components. You can just do those checks at runtime to make sure that your entity conforms to what you need it to have. And so same thing here, you can just check if this dot post exists and then do nothing if it does not exist. For simplicity, we're going to just assume it's going to exist. So this dot position dot x is going to be velocity dot x, or plus equals velocity dot x, and then this dot position dot y is going to be dot y plus equals velocity dot y. So that's going to move our ship based on the velocity set while we're pressing down the up key. So last thing, almost last thing before we can test it, is to add our thrust component to our ship entity. Okay, so now I'm going to press the up key and the ship moves, but it does not stop. So this would be the case where we're in maybe real space, but now I've lost the ship. We're in real space and you just don't slow down no matter what happens, but you lose the ship real fast. Right, but this is what works, and you have to overcome the force going in that direction before you can move back in the direction you're now facing. So this is all pretty reasonable physics for an asteroids game, or any space game except for this non-decaying velocity here. So let's add that. That's why we have our thrusting flag, is so that we can know when we've stopped pressing on the gas that we can actually slow down the ship over time. So to do that, in our update here, in our thrust component, if not thrusting, we are going to slow down our velocity. So velocity.x, and we're going to slow it down by multiplying by by like 90%, let's say, right? By some percent each frame. So velocity.y times equals, let's say, 90%. So if x was 100 on the first frame, then we're going to come here, we're going to multiply it by 90%. So then it'll be 90. On the next frame, 90 multiplied by 90% again, it's going to be, I think, maybe 81 or so, or something like that. And it's going to do that until it gets too close to 0. And then you can actually check once it gets close enough to 0, just set it to 0. You don't need to do that. It'll work fine even if you don't. So let's test this out and see if 0.9 is a good number or not. It does slow down, but it slows down really fast, right? So that is like a car, really, more than a spaceship. So let's change this to maybe 99. You can try 95, 98, 97. Whichever value. You can even go 99.99, right? You can go as large, as many decimals as the float will allow. So if we do this, we'll seem like it's almost not doing anything because 999 is, very close to 100. So let's just do 99. And that's not bad. That feels not bad. So you can play around with that number, but as you see here, we've got the ship movement, which is pretty close to asteroids. I've now lost the ship. So this feels pretty good, and you can still shoot. So if you take our shooting bullets video with this ship movement video, you can make yourself a pretty cool space shooting game, top-down space shooting game. All right, so that's it for this video. If you enjoyed this video, be sure to hit like and subscribe for more videos on making games with Kaboom.js and other web technologies like Phaser 3, Calicius, and others.